Good evening, students.
Good evening, sir.
Last class, what we have seen? Have we completed the inductive effect?
Yes, sir. Once again, I'll check, sir.
I think inductive and resonance effect we have completed. Electromeric hyperconjugation, everything we have completed. I think we have to go for the types of organic reaction. Same right or not? Am I right, ma? Today we have to go for types of reaction.
Yes, sir.
So, if you are seeing organic reactions, so we have many types of organic reaction. So we have to categorize what type of reaction is this. So if you are given, some of them get generally the organic reactions are broadly classified into. So you can classify up to eight also, but generally what they are classifying, no, substitution or displacement, reaction. Number 2, addition reaction. Number 3, elimination reaction. Number 4, rearrangement reaction. Other than this, we have condensation reaction, polymerization, number 7, isomerization, number 8, pericyclic. So now we are saying, first we will see one by one. So generally, any book you are taken up to 4 they were given, but you can further classify condensation, polymerization, isomerization, and pericyclic also. Now we have to see what is what. Substitution. The meaning of substitution. What is the meaning of substitution? Number 1, what is substitution? What is the meaning of substitution for? One player is substituted by other player, no? Likewise, any atom or group of atom which can be substituted one by another, then it is called substitution reaction. This substitution again classified into 3 types. One is nucleophilic substitution, electrophilic substitution, and free radical substitution. So how they are classifying? Nucleophilic substitution, electrophilic substitution, and free radical substitution. What is nucleophilic substitution? So generally the substitution reaction in which involves the direct replacement of atom or group of atom in an organic molecule by another atom or a group of molecule without any change in the remaining of molecule is called nucleophilic substitution reaction. Depending upon the nature of the species, it may be a nucleophile or electrophile or a free radical. Then the reactions are classified in 2-3 types. If the substitution reaction which are brought about by the nucleophile are called nucleophilic substitution. For example, hydrolysis of alkyl halide. For example, hydrolysis of alkyl. When you have RX, okay, plus if you are having OH minus, this OH minus go and attack over here, X will go. So it gives ROH plus X minus. So one of the minus is attacking over here, the minus will get removed here. So this is called nucleophile. So when you are negatively charged means it will nucleophile. So what is the difference between nucleophile and base? What is the difference between nucleophile and base, ma? Are you hearing?
Sir.
So what is the difference between nucleophile and base? Srinidhi, what is the difference between nucleophile and base?
Sir,
Hmm.
nucleophile will attack nucleus.
Hmm. So I'm asking, what is the difference?
Electrons.
What is difference between nucleophile and base? That's what I'm asking. Please remember, when you have negatively charged, for example, OH minus, you can call it as base as well as nucleophile. When it is base, when it is nucleophile, that we should know. So please remember, when the negatively charged particle which are forming bond with hydrogen, the ease of formation of bond with hydrogen is called base. The ease of formation of bond with the carbon is called nucleophile. So this is the basic difference. So difference between base and nucleophile. So when you have the negatively charged, if the negative charge taking H plus means you can say it is a base. If the negatively charge going to bond with the carbon means you can say nucleophile. Look here, this OH minus is attacking over the R, isn't it? Say yes or no. It's going to attack, no? See, look here, this one R. So this OH minus attacking R, it leaving X minus. So ROH is forming. So this ROH, okay, this ROH. So the OH is forming bond with the carbon. That's why it is called, the OH is called what? OH is called what? So I say the OH minus, the negatively charged species, which forming the ease of formation of bond with the hydrogen, then it's at base. The ease of formation of bond with the carbon, it's at nucleophile. Now you tell me the OH minus, or is the alkyl or alkyl or higher alkyl, methyl, ethyl, propyl, anything it can be. Then you would say, what is the OH minus? What is the meaning of OH minus? What is the meaning of OH minus, Pa? What is the meaning of OH minus? What is the meaning of OH minus? This OH minus. What is R? So I will write So I am writing CH3 Cl CH3 Cl. You are treating with NaOH. So generally this Na from the OH, you will get OH minus. This OH minus attacking, Cl is going, then it gives CH3 Cl plus CH3 OH plus Cl minus. You tell me what is the difference? So this OH is forming bond with water. The same way CH3 CHO, when you are putting OH minus, so this OH minus is taking H plus, then CH2 minus CHO plus H2O. This OH minus is taking the H plus. You tell me what is the difference between these two reactions? Are you hearing my voice?
Yes, sir.
You tell me, here the OH minus is forming bond with the carbon. Here the OH minus is forming bond with the hydrogen. What is the difference? The same sodium hydroxide, you are reacting with methyl chloride, it will give the methanol, CH3OH. Here you are using the acetaldehyde using sodium hydroxide. It will generate then carbene ion. So here what is OH? Here what is OH? When the negatively charged species, they form bond with the hydrogen, then it's a base. If it form bond with the carbon, I said nucleophile. Here OH is what? Here OH is what? First case OH is here. The first case OH is a what? So are you able to follow or not, ma? Mithran. Mithran,
Yes, sir.
you tell me. So in the first case, OH is behave as a what?
Sir, actually, in my school they didn't teach this, sir, and I have newly joined here, sir.
So okay, now I said no. OH minus is negatively charged. Okay, this
Okay, sir.
negatively charged, it can be base or nucleophile. Once the negatively charged forming bond with the hydrogen, then it's said to be a base. The negatively charged forming a bond with carbon, then nucleophile. Now the OH minus is what here?
Nucleophile.
Here, second case, second case,
Not sure with second case, sir.
you're not? See, so I'm writing, look here. So I am taking acetaldehyde, CH3, C double bond OH in presence of sodium hydroxide. It gives CH2 minus CHO. That means the 3 hydrogen you have in the acetaldehyde. Okay, the OH minus from the sodium hydroxide is taking up the hydrogen plus H2. Now you tell me. Here the OH behaves here.
Nucleotide, sir.
How it is nucleophile, ma? It taking and forming bond with the water hydrogen, no,
Okay.
H2O. Then it is a hello, are able to follow or not, all of you? Nalla gavaninga. That OH minus is negatively charged. So the difference between base and nucleophile. Once the negatively charged forming bond with the hydrogen, it is a base. If the negatively charged forming bond with the carbon, it is a nucleophile. Is it okay?
Okay, sir.
Now you tell me what is this?
It's a wish.
For this, I have to give full energy, no? Then only you will say, okay. So the substitution, second substitution is called electrophilic substitution. That is, one of the electrophile can be replaced by the other electrophile, then it is called electrophilic substitution. The benzene ring, you have 6 hydrogen, 6 carbon. So one of the hydrogen get replaced by the chlorine in presence of AlCl3. So now you look this. So this hydrogen can be replaced by the chlorine. The rest of the things does not affect. So nalla nyabam vechunga, during substitution reaction, hybridization won't change. Will not change. Okay. So inga parunga. இது வந்துட்டு இது கிடையாது, சப்ஸ்டிடியூஷன் கிடையாது. அத பண்ணிட போறீங்க. This is not substitution. For base and இதுக்கு தான் சொல்லி கொடுத்தது. So inga parunga, methyl chloride you have taken, you are getting methanol. So this carbon is attached with 4. What is the hybridization of this carbon? What is the hybridization of this carbon? That you can answer, no? What is the hybridization of this carbon? What is the hybridization of this carbon? What is the hybridization of this carbon? Hello,
Sir, is
Yala,
it SP?
Yes, SP.
3, sir.
Very good. What is the hybridization of this carbon? What is this hybridization of this carbon?
Sir, sp3.
So look here, the starting material sp3, product also sp3. So during the substitution reaction, the chlorine is substituted by OH. That's all. So it won't change. Look here, in the benzene ring, what is the hybridization of this carbon? So it attached with 1 nitrogen, 2 carbon. What is the hybridization of this carbon? sp. sp.
2.
So look here, for this carbon, it was attached with 1 chlorine, 1 carbon, 1 carbon. What is the hybridization? sp. sp.
3, sir.
How it is 3?
sp2.
What I said, please remember, when the carbon attached with 3, that means 1s plus 2p. So it gives sp2. Okay. If the carbon attached with 2 atoms, 1s plus 1p, then it will become sp. If the carbon is attached with 4 atoms, so it use 1s orbital and 3p orbital, it becomes sp3. So you have 3 type of hybridization only in this organic molecule. Okay, not more than that. So you can easily say how many atoms get attached. Based on that, you can say sp, sp2, sp3 for the organic molecule. So then, free radical substitution. when you have the methane molecule, in presence of chlorine, the light, it will give CH3Cl plus HCl, methyl chloride. Further it continue, it will give CCl4. So then 4HCl, so 3HCl. So this reaction is known as photochemical reaction. The methane, one of the chlorine, all the chlorine get, so all the hydrogen get displaced by the chlorine. This is called free radical substitution. So what happens when you put Cl2 in presence of light, it will give homolytic fission, Cl dot plus Cl dot. This Cl dot, what it will do? No, it will cleave the carbon hydrogen bond. So further, next time we are going to see. So it will cleave, then it gives CH3 dot plus HCl. So it will create a radical, it will goes. So that's why it is called substitution. The next, what we are going to see is the addition reaction. So addition reaction means we have to add. Okay. So reverse of substitution only. Addition is so substitution taking place in the saturated and unsaturated compound. Addition reaction, if the compound having multiple bonds, C double bond C, C double bond O, C triple bond C, there only you can get it. So here what will happen? Unsaturated become saturated. So it comes to that. If it does have triple bond, it become double bond. Then double bond become single bond. Then it is called, or otherwise sp can be converted to sp2, sp2 can convert it to sp3. So it will come like that. So during the addition reaction, hybridization can be changed. So what is addition reaction procedure? Definition: reaction which involve combination between two reacting molecules to give a single molecule. Then means you are adding, are called addition reaction. This reaction undergo only compound contain double or triple bond. So depending upon the attacking species, if it is nucleophile or electrophile or free radical, so this reaction also can be classified nucleophilic addition. Nucleophilic addition, electrophilic addition, and free radical addition. First, what is nucleophilic addition means? Same way, nucleophile means negatively charged. So if you have the carbonyl compound, when react with Cn minus, so the Cn minus will attack the carbonyl carbon. It goes like that. So it gives RCO minus, then Cn will attack and R dash. So when if you put it to the water, it gives RCOH Cn R dash. So cyanohydride you get. So you started with this carbon. What is the hybridization of this carbon? What is the hybridization of this carbon? It attaches with how many atoms? It attaches with how many atoms?
3.
Then
sp2.
sp2. Look here. What is the hybridization of this carbon? It attaches with 4. Then it becomes sp. sp. It attaches with 4. Then it becomes
sp3.
For all of you have to answer, ma. Otherwise, the class will not be interactive at all. Okay. Then if you are answering, it will come to in your mind. Why you people keep quiet? Huh? The next. So this is the nucleophile attacking, and then you are getting that product. That's why it is a nucleophilic addition. Suppose if you are having so simple Marconic approach CH3, CH double bond, CH2, you are going to add HBr over here. Okay, HBr means H plus Br minus. So first you have to add the H plus. Okay, if you are adding H plus, so now it is a positive charge. Positive charge means what is this? Electrophile or nucleophile? Positive charge means electrophile or nucleophile.
Electrophile.
So the electrophile you are going to add. So if you are adding CH3, it may go like this or it may go like this. Either one nadakkum. Appo enna agum? CH3 first one CH3, then it become H plus. According to the first marking, you will get like this. Suppose if it is goes, the double bond get migrate over here means you will get CH3, CH2, CH2 plus. There are two possibility. You can get this one and this one. So this is what cation? Primary or secondary? This is what type of cation? Carbocation. Primary or secondary? First one, green color. So the carbon positive charge which are attached with two carbon, then it become whether it is primary carbocation, secondary carbocation, or tertiary carbocation.
Primary.
It's a primary, yeah. So how you can say primary, secondary, and tertiary and all?
Secondary, sir. Sorry.
This will become the carbon which is bearing positive charge attached to one carbon. Then it become
Primary.
so you know that tertiary carbons are more stable than secondary, which in turn is more stable than primary. So among the two, this will become more stable because two positive plus I group, methyl group can donate electron through the sigma bond. That's why they are stable. Or otherwise, through the hyperconjugation, it is stable, isn't it? These are the things you have studied. Then the Br minus is attacking. It goes to this place. Then you will get the product CH3, CH, Br and CH3. So 2-bromopropane you are getting here. So what is the type of addition? The carbon-carbon double bond become carbon-carbon single bond. So what happened? First step, the electrophile attacking, and then you are getting bromine attached. So this type of reaction is known as electrophilic addition. And the third, you can take the CH3, CH double bond, CH2. So same hydrogen bromide you are going to add, but in the presence of peroxide. Once if you are adding peroxide, that mechanism will vary. How it will vary? No, look here. So when you are adding HBr with hydrogen peroxide, this will become the hydrogen peroxide. So the hydrogen peroxide in the light, it will become HO dot, HO dot. So symmetrical cleavage can taking place. It gives you 2OH dot. Okay. So it will give the 2OH dot. This 2OH dot can be reacted with HBr. So what happened? It will give single electron. It will give the single electron. It will give. So it gives HOH water plus Br dot. First step, it form a Br dot. Now this Br dot going to attach with your propane. So Br dot means it symmetrically cleave. Once it symmetrically cleave means you will get CH3, CH dot and CH2 dot. So if you are adding, you can add two. So one thing CH3, CHBr, CH2 dot and CH3, CH dot, CH2 Br. So among the two, this is the what type of free radical? the single electron is there, it attached to one carbon, then it is a what free radical? Primary, secondary, or tertiary? Carbocation எப்படி சொன்னீங்களோ அதே போல சொல்லுங்க. Same, whether it is a free primary, secondary, or tertiary. The carbon which is having a odd electron. This carbon
Sir,
having
primary.
odd. No, it's a primary. For this,
Secondary.
secondary. So among these two, which is more stable?
Sir, the other one.
Secondary is more stable, right? So always, because this group can donate the electron, sigma electron, through it which it can be stabilized. Okay, here the bromine attached, so it cannot donate the electron. Here it can. The next step, so you can add the H dot. So if you're adding H dot, the product what you will get it CH3, CH2, CH2, Br. So look here, the propene only, here also you are taken. So here you are taken the propane CH11CH2. So you are ending with the 2-bromopropane. Here you are taken the same one propane in presence of HBr, but you are added additional to the hydrogen peroxide, but you are getting 1-bromopropane. Here 2-bromopropane, here 1-bromopropane. What we are getting? 1-bromopropane. So what is the difference? The reagent is different because this reagent generates a free radical. So since it's free radical, the addition is taking place through the free radical. Since it's a electrophile, the addition is taking through place electrophile. That's why it is a addition. So we are saying it is a free radical addition reaction. So next we are going to see the elimination reaction. Elimination reaction is a reverse of addition reaction. So it becomes reverse. So saturation become unsaturation. So in the elimination reaction, one that involve loss of two atom or group of atom from the same or adjacent atom of the substance to forming a multiple bonds, then it become elimination reaction. So depending upon the portion of atom get displaced, then the elimination reactions are classified into alpha elimination, beta elimination, and gamma elimination. If the eliminating groups are which are present in one and one for same carbon itself, then it is called 1-1 elimination or alpha elimination. If the two groups are removed from first carbon and the second carbon, the adjacent two carbon, then it is called beta elimination, 1-2 elimination or beta elimination. If the groups are present first position and the third position, then it is called gamma elimination. Look here. So we have the CHCl3. That means carbon which is attached with hydrogen, chlorine, chlorine, chlorine. When you are putting sodium hydroxide, so it will generate here CCl2, CCl2 plus H2O plus Cl minus. So the OH minus will take the first H plus, and then it will take the Cl minus, it will generate a carbene. Okay, but the hydrogen which are attached to the first carbon, the chlorines which are attached to the first carbon, the two things are removed in the same carbon atom. That's why it is a alpha elimination. And then you take CH3, CH2, OH. Now you are going to eliminate a water molecule. So the OH from here, hydrogen. So the hydrogen from here. So the hydrogen and OH are removed from the adjacent atom 1 and 2. That's why it is called beta elimination. CH2 double bond CH2. Then it is called beta elimination. Or otherwise, when you are taken a aldol condensation, these are the reaction we are going to study. So now the hydrogens and the hydroxides. It's going to remove 1 and 2. So it's going to give CH3, CH double bond, CH, CHO. So you are getting forming a double bond. Then it is called beta elimination. So the functional group attached to carbon alpha and then it is a beta. So this is called beta. So you have alpha. So this is alpha, this is beta. That's why you are saying beta elimination. Suppose if you are having group CH2, 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 Br, Br. So 1, 2, 3. Now you are putting zinc. So what will happen? This bromine can goes. It will give CH2, CH2, CH2 linked. So look here, cyclopropene. So first and third position, alpha, beta, gamma. So the two groups are eliminated in the 1 and third position. Then it is called gamma elimination. Are you able to understand? Is it clear, ma'am?
Sure.
Yes. Any doubts?
Yes.
Any doubts? Any doubt is there means let me know.
No, sir.
அது மட்டும் நல்லா கரெக்டா சொல்றீங்கப்பா. எதை சொல்றீங்களோ இல்லையோ. So this is called alpha, beta, and gamma elimination. Okay. So next, what we are going to see is the condensation reaction. So the name itself, it has the name that is condensation. You are going to condense something. When the two molecules of the reactant reacted, if it is eliminated, small molecule like water or HCl or NH3, or it can liberate carbon dioxide. Okay, so it forming a compound, then it is then the reaction is called condensation reaction. So what is the meaning of condensation? This reaction, two or more molecules of the same or different reactant combine to form a product with or without elimination of simple molecule like H2O, HCl, NH3, and then alcohol is called condensation reaction. Okay, so for example, you are taken acetaldehyde CH3 CHO and CH3 CHO in the presence of sodium hydroxide. Okay, so it will form a CH2 minus, it will attack over here, then it will give CH3 CHOH CH2 CHO. So the same molecule getting doubled. Okay, one of the, so what will happen through this reaction? This will be the aldehyde. So this is also aldehyde. So this aldehyde in the presence of sodium hydroxide, the OH minus will abstract the proton, then it becomes CH2 minus CHO. This CH2 minus will attack the carbonyl carbon, then it becomes like this. So it gives CH3, CO minus, that hydrogen will be there, the remaining CH2, CHO. So when you are putting H plus water workup, it will take OH. So then become OH. So what happened during this? It can be formed a aldol, hydroxyaldehyde. So if the hydroxyaldehyde, further if you are heating, it will remove the water molecule. That is from that is from hydrogen and then hydrogen. So it goes, it will leave the water molecule, it gives the product. If you are heating, use CH3, CH double bond, CH, CHO. So with or without elimination of this molecule, it gives the condensation reaction. So another example, simplest example for the condensation reaction, you can take a benzaldehyde. When it reacts with hydroxylamine, it gives the oxime. Okay, so this oxime, so what happened, this H2 and O, it will go as a water molecule. The mechanism will learn later, but this is called condensation reaction. These are the types of reaction. Apart from that, we have polymerization reaction. What is the meaning of polymerization, ma? What is the meaning of polymerization? What is the meaning of polymerization? We have to polymerize. So if you are taken a wall, the brick is called a monomer and the wall is called polymer. So the same monomer has been repeated with some binding, no? Here it has connected me, then it is called polymer. So the polymer are the larger molecule which is made up of the small repeating units. The small repeating units are called monomer. So the process by which the monomer molecules are linked to form a polymer is called polymerization. So polyvinyl chloride, PVC. So you have to take the vinyl chloride. So what is the vinyl chloride? CH2 double bond CHCl. Okay. So this vinyl molecules keep on. So you are taking one more vinyl molecule. What will happen? This will become form a bond. So it gives CH2 some bond, CHCl, CH2, CHCl, it goes. So whatever this unit going to be repeat, then it will put as a n times. So how many molecules we have taken? So then if you are saying the mass, you can say what is the mass of the polymer. This is called polymerization. And the next reaction, rearrangement. So rearrangement only taking place for the stability of the molecule. Okay, so the reaction which involve migration of atom or group from one atom to another atom within the molecule are called rearrangement. Okay, so what is the driving force of this rearrangement? To get maximum stability. For example, if the molecule having CH3, CH3, CH2, Cl. When you are taken this, if you are treating with AlCl3, it will take the Cl. 1 minute. It will take the Cl minus. So then it will give CH3, CH3 and CH2 plus AlCl4 minus. Okay. Now this is the primary carbocation. All of you know that the carbon which is attached to one carbon, two hydrogen, then it is primary carbocation. So what happened? This group get migrated to give CH3, CH plus CH2, CH3. Now the primary carbocation become secondary carbocation. So this will be more stable than this. So during this reaction, if you are hydrolyzing by using AlCl3 or doing some reaction in presence of Lewis acid, means it will isomerize. So what is this? 1-chloro-2-methyl propane. Now it become, now if you are treating with some chloride means you will get CH3, CHCl, CH2, CH3. So the 2-chloro-butane you will get. This is called rearrangement. So why the rearrangement will take place? No, for the stability of molecule. So இது எங்கேயும் போயிடல, வெளியே இருந்து வரல, ஒரே மாலிகுல்லே மாறி மாறி இருக்கு. Then it is called rearrangement. And the isomerization reaction. So isomerization reaction the same thing you can take. So இதுல என்ன இருக்கு, இதுல இருந்து இது மாறி இருக்கு இல்லையா, ரீஅரேஞ்ச் ஆயிருக்கு இல்லையா. இப்போ இதுல இது கூட இன்னொன்னு ரியாக்ட் பண்ணீங்கன்னா என்ன ஆயிடும்? So இந்த பொசிஷன்ல இருக்கிறது மாறி வர்றது தான் ஐசோமரைசேஷன். I will write the example for that. Isomerization. S போடலாம், Z போடலாம். So the reaction which involve interconversion of one isomer into another by keeping the molecular formula as well as the carbon skeleton of the reactant and the product are intact are called isomerization reaction. For example, you can have the 2-butene. The 2-butene across the carbon-carbon double bond, 2 hydrogens are in the opposite, 2 methyl are in the opposite. It's called trans isomer. When you are heating, when you are keeping this in presence of light, it can be interconvert CH3, C double bond C, CH3, HH. So what is the difference? Hydrogen on the opposite, then it is called trans. Same groups on the opposite, same group on the opposite are called trans. So here methyl, here methyl. So the same group on the same side, then it is called cis. So this form into this form is called isomerization. Or otherwise, you can take 1-chloro CH3, CH2, CH2, Br. So 1-bromopropane. So in presence of AlCl3, it can be converted into CH3, CH, Br, CH3. So it can be converted to 2-bromopropane. Then it is called isomerization reaction. You may ask how can it will happen means. So in presence of AlCl3, sorry. This AlCl3 will take the Br minus. So it gives CH3, CH2, CH2 plus. Since it's a primary carbocation, you have 2 hydrogen over here, right? So one of the hydrogens with pair of electron get migrated to over here. When it's migrated, CH3, CH plus CH3, you will get it. So now it become the primary become secondary. It get more stable. When it react with the Br minus, it will give 2-bromopropane. This is called isomerization. One of the isomer get changed. So first carbon will attach on a bromine, second carbon on the. This is called isomerization. And then pericyclic reaction. So what is pericyclic reaction? There are certain reactions which are initiated either by heat or light. Okay, they do not have ionic or free radical intermediate. It can proceed through cyclic transition state. In this reaction, bond breaking and bond making occur simultaneously. So this is called concerted reaction. They do not have any ionic like this. இந்த மாதிரி மெக்கானிசம் எல்லாம் எதுவுமே இருக்காது. அதனால அது concerted reaction. So this is known as pericyclic reaction. For example, when you have the butadiene, if you are reacting with alkene, it will form a cyclic compound in presence of light or heat. Okay, or otherwise, when you have the very strained ring in presence of heat or light, it will give cyclobutene. So this is called pericyclic reaction. So is it okay, ma? Is it clear? Any doubts? Any doubt is there?
No, sir.
What? Any doubt? நீங்க பேசுறது கேட்கலப்பா. ஏதாவது டவுட் இருக்கா?
No, sir.
கிளியரா? Is it clear no? So now we are going to the, it's clear no?
Yes, sir.
Purification of organic compound. So whatever we are getting the organic compound from the natural source, or we are synthesizing in the laboratory, which will contain the impurity. So you have to purify for the normal purpose, for whatever in the industrial application, or if you are using in the medicine, so it should be clear. So the purification of organic compound simply by what are the methods which are available. So sublimation, crystallization, distillation, extraction, and then chromatography. Okay, these are the method by which you can purify the organic compound. So each and every method has some principles. So based on the principle only, we can purify our organic compound. Today we will complete that sublimation and crystallization, and then solvent extraction. So what is sublimation? So if the compound should be in the solid, if it is volatile, then when the solid directly pass into vapor, so solid to vapor, without converting as a liquid, when heated, the solid substance which is directly converted into vapor, so the solid phase converted into vapor phase, and the vapor is cooled. Okay, so without the intermediate formation of liquid is called sublimation. Okay, this substance which can sublime can purify by this method. Whatever we have the camphor we are burn it, no, what will happen? It can be converted into, we have the camphor in our home. If you are burning that camphor, what will happen? What will happen, ma, for the camphor?
Will become vapor.
It become vapor. It doesn't convert it into what liquid state. So this is known as sublimation. So we have in our house, we have the naphthol balls. The toilet la போடுவாங்கல, toilet and dress la insecticides வராம இருக்கிறதுக்கு. அதை எடுத்துட்டு just we are heating னு வச்சுக்கோங்களேன், what will happen? It become vapor மாறும். Vapor தான் மாறும். அது ஹீட் பண்ணினா நல்ல பக்காவா சப்ளைம் ஆகும். So this is known as sublimation. So இந்த sublimation எப்படி பண்ணுவாங்கன்னா, they will take in china dishல solid எடுத்துப்பாங்க, அதுக்கு மேல they will cover the inverted the funnel. Okay, so funnel invert பண்ணி வச்சிருப்பாங்க. Okay, இதுக்கு இடையில வந்து filter papers இருக்கும். Filter papers with the porous-ல இருக்கும். So if you are heating, உன்னுடைய compounds இங்க வச்சிருக்க, உன்னுடைய organic compounds இங்க வச்சிருக்க, இது ஒரு tripod standல வச்சுக்கோங்க. So heat பண்றோம் compound. It goes like this. Then the whatever were organic compounds inga vechinga illaya, after some time it will sublime into the cooler part of the funnel. So the funnel can be you have to put it over the cotton. இங்க வந்து cotton வச்சிடணும். So it's sublime out. This is called sublimation. So what are the substance you can purify this method? The impurities left in the China dish itself. It won't sublime. So the substance which are easily sublime that can be purified by this method. So camphor, naphthalene, anthracene, benzoic acid, phthalic anhydride, anthraquinones are sublimed by this method. So only thing, it has to convert solid into vapors. For that substance, you can convert it through the sublimation and then crystallization. So what is the crystallization means? You have to make it into a crystal. Whatever we are getting, it's a powder form. The powder form we can convert it into crystal. For that, you have to you have to choose a suitable solvent. This method is most common for the solid. So sublimation, crystallization, mostly for the solid substance. These two are for the solid substance. So solid sublime ஆச்சுனா, you can go for the sublimation. Sublime ஆகல அப்படின்னு சொன்னா, we can go for the crystallization. So the only thing, இதுல வந்து yield will be lost. இப்போ வந்து if you are having 10 to 20 grams means after crystallization you will lose 4 to 5 grams. If you are getting 15 grams, that is a good yield. நீங்க benzoic acid வந்து crystallize பண்ணனும். You are taking 20 gram of benzoic acid, but you are able to get only 15 gram means the yield will be lost in the crystallization. That is the main disadvantage in kuda solla. But the purity will become 99.99%. So for this method, you have to choose a solvent which are partly soluble at room temperature. So ஒரு substance எடுத்துக்கணும். You have to create a saturated solution. What is a saturated solution? Now, you are taking a tumbler of water. Okay. You are adding 1 spoon of sugar. You are mixing. What will happen? It will dissolve. You are adding 2 more, second, third, fourth. Then it will dissolve or not? You are taken a small tumbler of water. In that you are adding one spoon of sugar. It will dissolve. Second spoon. Hello, DS. You have to answer. Then only it will be interactive. Otherwise, how you can learn, no? You are adding second spoon of sugar in that water. What will happen? It will dissolve or not?
Yes, sir.
Third spoon.
Yes.
Fourth.
No.
So what will happen at the time? Some of the substance will be remain in the solution, right? It is not dissolved, but it will present in the solution. Correct? So sugar எடுக்குறீங்க, 3 spoon of sugar, it's completely dissolved. When you are adding the 4th spoon, it will be settled. It will be as such, isn't it? Yes or no? சொல்லுங்கப்பா, இருக்குமா இருக்காத சொல்யூஷன்ல?
Yes, sir.
So you have the 4th spoon of salt or sugar will be present in the solution. So this solution is called supersaturated solution. When you are drinking that water, it becomes too sweet, right? Yes or no?
Yes, sir.
So that solution, you have to heat it. So while heating, what will happen? That will be dissolved. Whatever which is not dissolved, it get dissolved. Then you have to take that solution and keep it aside. So it will take a time, but slowly the purest form of the substance will crystallize out of this solution. Okay. So after that, if you are filtering, that filtrate whatever liquid coming from that filtration, it contain impurity. Whatever crystals crystallize from the solution, it become 100% pure or 99.99% pure. So if you want the solid substance that should be in purest form, means by using crystallization you can purify. Okay. So up to this today class we can wind up. You have the maths class, no?
Haven't sir.
What?
WhatsApp group it is sent that the maths class will be at 7 sir.
Shall we continue for some time? Another 10 to 15 minutes will complete the crystallization. Okay. Hello. Sir, okay. Now you can leave. Tomorrow we will meet in the classroom. Okay. Now you can leave. Pa.
Thank you sir.
Thank you, sir.
Mhm. Wonderful.